Well, hello, welcome back to the program. We've been working on our programming language, Natalie, which is a Ruby implementation transpiled to C++. And it's been a while since I've done a video, so I thought I'd do a quick one here to get back in the swing of things and work on the Enumerator class, which we don't have yet. We have a numerable module, which gets mixed into things that can be enumerated, but we cannot return an enumerator because we don't have a numerator. You can tell I have a lot of fun saying those different words. So I thought we'd just do the bare bones of this. But first, I wanted to do just a quick tour of fibers. This episode brought to you by Fiber. Uh, so Ruby has a thing called fibers, and I'm not going to pretend to know all there is about concurrent programming, but I do know that fibers in Ruby are essentially asynchronous coroutines. Each fiber gets its own stack, and as long as that fiber lives, that stack lives with it. And when a fiber is executing, then that stack is switched in, and that is what's being used. And each fiber gets to signal when it is ready to give up the process, and then control is handed back to the main process, for lack of a better word, I guess main fiber. Internally, I implemented that as the main fiber, and the main fiber, can continue to say, okay, now yield to this fiber or that fiber or whatever. So it's all cooperative. It's not like threads because each fiber needs to cooperate and signal when it's ready to give up control. But the really cool thing about this is you'll see this big old copyright. This is one of the first files in Natalie that has this big copyright notice because I stole or borrowed a bunch of code from a good gentleman, Evan Jones, who was kind enough to put this library on GitHub. And I'm not going to go over the whole thing because I think it's a little tedious, a lot of the setup and boilerplate, but some of the fun stuff is this create stack method, which obviously creates the stack. It does a malloc of the memory used for the stack, and then it sets up some return addresses on the stack, and that's where the magic comes in for being able to switch control of fibers, and sets up these return addresses. I should put return addresses in quotes because it's kind of abusing the return instruction to jump to the fibers, and every time you're jumping to a fiber, you're actually returning to it, which is kind of cool. I don't think I could have written this code. In fact, I'm very sure I couldn't have written it, but now that I'm able to copy this from our good friend Evan Jones, then we got fibers working, which is really cool, and I'll show you how fibers work in just a second. But the other cool part about fibers here is this bit of assembly code. And again, I couldn't have written this, but I'll try to explain what's happening. The comments help a lot. So whenever we're ready to switch to a fiber, we set up the return value and we push all the important registers onto the current stack for the current fiber. And then we move some arguments for the function, the fibers function. Each fiber gets a function that gets run. We move those arguments into place, and then we swap out the stack. So we point the stack pointer to the stack for the new fiber that we're switching to, and then we restore the registers from that stack into these important registers, and then we do a return in quotes, which jumps to that return address that I showed you earlier, and runs the function, runs the fiber. And and so this same function is called whenever we want to switch out from a fiber. it does the same thing again, but just in reverse because it's switching to back to the main fiber. And yeah, so this is the guts of it. And I only worked on the only worked on the 64-bit portion because that's what machine I have. I haven't even tried to compile Natalie in 32-bit, but once we do that, then we can work on this 32-bit section. And this was really fun. I haven't written assembly in a long time. Did it a little bit in college, but I don't remember any of that hardly. So this was a lot of fun to work with. And so anyway, that's a quick whirlwind tour of fibers. And let's see if I can just show you an example. So if I say, actually, yeah, I was thinking maybe another example, but that's okay. We'll do fiber new, and we'll say it's going to print a 1, and then it's going to yield back to the main fiber, and then it's going to print a 2. And so this will just at least demonstrate that they can be paused. So if I say, so I have this fiber object, and you can see it's created. And if I do fiber.resume, then it prints the 1, and then it yields back. Now I didn't pass anything in the yield, so I got a nil, but you can pass arguments back and forth. And so now if I look at the fiber, it's suspended, but it still exists. If I do resume again, then now it prints the 2, and it yielded back again. And if I look at the fiber, it's terminated. So if I try to resume it again, then we get this fiber error, dead fiber called. So that's how it works in Ruby. And I should have ran this in Natalie, but it essentially works the same way, except I need to work on inspect. So when you inspect, when you inspect a fiber in Natalie, it does not look that cool. Oh no! Okay. Apparently broke something. Let's just do a clean build. My webcam is a little bit laggy. Hello? Are you there? Let's try that again. Yay! Okay, so this was what a fiber looks like in Natalie. Doesn't look as cool. It doesn't say suspended or created or whatever. But it does work. It does that, and it does that, and it does that. Dead fiber. So very cool. Very cool abstraction to build on, and that's what we're going to do today. We're going to build on that abstraction. We're going to build a numerator. Enumerators work on top of fibers. And so, not going to do all of this today, but we're going to get started. And I guess we want to do something just like this. In fact, this would make a good test. So make a great test. So let's get out of that. Test Natalie enumerator test.rb, and just gonna copy some stuff over here. Works. And let's paste that in, and yeah, instead of printing it, we should do this. Should equal, and to make sure that works in Ruby, nope, not fiber test, enumerator test. Okay, it does work. So this is going to be our test case. I'll set up our normal process here. We'll do a make bin Natalie test. Actually, there we go. And yeah, failing test, and we'll be all ready to rock and roll. Ready to rock and roll. Source enumerator.rb. Let's create this thing. And let's also do this. Star.cpp, star.rb. My little enter. I don't know how to pronounce that, but it looks like enter to me. Wait, what? What do you mean? No regular files RB. Oh, star.rb. Silly me. Okay, so it compiled our new enumerator file, and so now we have a enumerator class, but we don't have the take method. So to get that, we're going to do enumerable. So it gets the take method, but now it's not going to have the each and everything else. So yeah, so let's just get started doing that. How are we going to do this? How are we going to do this? Um, well, we know that it takes a block, and we're going to have to store that somewhere. So let's do initialize. We're going to take a block, and let's just store it in an instance variable. And we're going to need an each, and then inside of here we're going to do yield a bunch of times, but we're not going to do it ourselves. We want the block to do it. And how does that work? So it looks like there's an argument passed into the block, and that's the y. What does it say that is? Oh, right here. Iteration is defined by the given block in which a yielder object given as a block parameter can be used to yield a value by calling yield on it, also aliased as less than less than. Cool. So out of curiosity, if I do enumerator.new, how can I get that to actually do something? Okay, there we go. Enumerator yielder y equals nil. I just want to capture that thing. Actually, I don't know. Why? Y is nil. And I want to capture that here. There, right. Oh, I don't have it. Oh, right. So let's do this. Now do I have it? Yeah, there it is. So YY is a yielder, and its class is yielder, and its super class is just object. Okay, fair enough. That's pretty simple. There's nothing too complicated about that. It's class yielder. And it's going to have a yield method, I know that. And it's going to be alias. I always get these backwards. I don't remember if it's the alias name first and then the... Actually, I think it's the other way around. Let's try that. Okay, so the yielder is going to, when yield is called, what's going to happen when yield is called? I think it's just going to call fiber.yield with the item, possibly. Yeah, because it's going to run in a loop, and each time through, we want to yield to the fiber, and then when it's resumed, we want to continue, and then loop again, and then yield to the fiber. So all that yielder thing is doing is just doing fiber.yield, I think. And in here, I think we want to do a loop because we want to at fiber, let's create our fiber. Fiber.new do block.call. Is that right? And this is kind of hurting my brain a little bit. Loop do, and then we want to do fiber.resume each time through here, and we want to yield that to the block past each. Okay, I don't know. I think I'm missing some stuff, but let's just see. Oh, we got like a really nasty seg fault. I think that means I got this backwards. I knew it. There we go. That's a little bit better error. Okay, so undefined method less than for... Oh, because I didn't pass in the yielder dot new, or should I say yielder equals yielder.new and then pass it in like this. Don't need to create it every time. That actually passed. Fascinating. Now, I expected a problem here because I expected this to throw an error when it got to the end. Oh, there is no end. This is unlimited. Okay, so we need a new one. I'll say it works for unending sequences. I don't know. I'll say it works for what's the opposite of unending? Finite. I'll say infinite. Infinite. It works for finite sequences. And let's just make another one here, but this won't be fib. It'll be, I don't know. What's something that's finite? I don't know. Just do numbers. And let's make this a lot simpler. Say y is 1, 2, and 3. And so say numbers dot 2a should equal 1, 2, and 3. That one should fail because we should get a fiber error. Yes, dead fiber called. So now we need to do something here. So if we rescue fiber error, then, I guess we just don't do anything. No yield. Oh, we do need to do something. Oops. We need to break out of the loop. Okay, 1, 2, 3, nil. Interesting. So fascinating. What have I done? Begin, rescue. Well, this should have worked right here. Yield fiber resume. Why would that? Why would that return a nil? Why would that yield? Why would that ever yield a nil? Let's just run it through Ruby just to make sure. That could be a misunderstanding on my part. No, okay, so it definitely works in Ruby. And just to really double check here, if I put a nil here, Ruby doesn't do anything about removing that, right? No, okay. So somehow Ruby knows when the enumerator is finished. I'm going to try this again. Result equals yield result. I don't think that makes a difference, but maybe. And it gets stuck in a loop. What in the world? Stuck in a loop. I don't understand that. kind of says bug to me. Bug in Natalie, not a bug in how I'm writing this. But I'm not in the mood to debug that right now. Just out of curiosity here. Oh, yeah, look at that thing go. Now, how is this break not actually working? Okay, so let's do, this is the error, and this is after the error. It's going to be kind of janky. Look at that. What does that even mean? I think it means my break is not working. Ugh, well that's dumb. Well, that's a problem for another day. Break is not working right. And that still didn't fix it. So it didn't matter if I do the yield here or not. Still have the problem that I had. So, okay, refresher here. If I have a fiber, and I print a 1, I'll say, let's do this. Fiber dot yield 1. And that's it. If I do f dot resume, I get a 1. And if I do it again, I get a nil. So even if you don't call yield, you always get the final result. And is that the same in Ruby? Make sure I didn't mess up fiber stuff. Resume. Can't type because my fingers are cold. Yeah, okay, so the fiber is working properly, but the enumerator, it needs to know not to include the final nil. How does it do that? How does it know? Okay. If I have a fiber, and does it have a status? F.methods. Let's just see what methods it has. It only has raise and resume. Oh golly, stop. Raise and resume. There's no way to see if it's finished. So I think the only way to know if it's finished is to call resume again, and we see the fiber error. But it'd be nice if I could know that it was finished before that, and then I could ignore the nil. But there is no method for that. I wonder if Ruby's doing something internally, even though there's not a method on the fiber itself. Maybe internally Ruby knows that the fiber is finished. So what if we do that? What if we do fiber HTTP and we say status. Actually, I want this to be a string, I believe. Status return. Well, let's see here. What are our statuses? These are our statuses. Switch m status. Probably have to do status like that. And let's return is this a good way to do this? I don't know. Suspended. Suspended. And last is terminated and terminated. I don't want a default case because I want C++ to yell at me if I forget to update one of these. And this has to be a new string value v. Maybe? Doesn't know about string values. I could just include that here. Oops. String value. Okay, that makes you happy. So now I have a status, and then we'll go to bindings gen, and we'll add that to fiber. Say status. Yeah, that should have been a symbol. Now that I think about it. Okay, so 0 args, pass the environment, return value. So I don't want this. I want this to be a symbol value. Now that I think about it. And this should be symbol. Oh, and that's not how you do a symbol, of course. You have to call intern on it. Turn. This is, sorry, this is like gross watching me type this out. It's probably the slowest possible way. Oh, goodness gracious. There we go. Okay. So if I run make, control reaches end 170. I mean, it's not ever going to get here. It shouldn't. Okay, that's good. And I do bin Natalie fixed fiber.new fiber.yield1 f.status is created, f.resume f.status is suspended. Oh, right, but that's perfect. So now it's going to be dead, terminated. Perfect. So now I know if I get a nil and it's terminated, then I don't need to call resume again. Perfect. Just real quick though, what if you have a fiber? What if you have an enumerator? Let's do this on one line. I just answered my own question just by typing it out. I was thinking, like, what if this returns a value? That's never going to be anything, right? Yeah. Okay. So I think we can do this. We can say result equals result equals that. Yield result unless fiber.status is terminated. Does that make our Test pass. Yay. Okay. All that's good. Um, I mean, I think this is like a cool API to have anyway. I mean, we're deviating a little bit from Ruby, but that's okay. Down the road, we may figure out if there's some other way that MRI Ruby, Matz's Ruby interpreter does this. But for now, I think that's good. I did think of one more thing to test. What if we call this twice? And actually, let's just say we'll take 5 numbers. This passes in Ruby, right? Okay. And it fails in hours. That's what I was afraid of. Okay, so it fails in hours because I set up this fiber in the initializer, but I think I need to set it up maybe here at the beginning of the each, and that means this doesn't need to be an instance variable anymore. So does that make that pass? Yes. Okay, boom. Hey, well, we built Enumerator, and that wasn't too bad. Look at this beautiful code that makes heavy use of the fiber primitive. It's beautiful. It's amazing. I just can't get over how awesome that is. This is probably not fully correct, and when we bring in the Ruby specs for Enumerator, we'll find all kinds of other little stuff, but I always like doing it myself without the specs, writing my own specs. I don't know. I think it's just more fun, and I get to learn how things work internally. And yeah, that's it. So, hey, thanks for hanging out with me today, and I hope you're having a great one. I hope you're piddling, banging away on some side project that makes you happy. And thanks for hanging out with me as I do that on mine. And I guess I'll see you next time. Bye.